movements of on-the-spot live streaming and vlogging, simultaneous wide and heavy live streams. This is again a singer. I am a singer, Eternal Focus, your YouTube content creator. Let's go back to the main content and topic of this particular discussion. So electronic configuration. Okay, like this. Okay, I have now to draw this because this is the basis really. Okay, you get the point. Okay. Now, we go first to the energy level. Energy level is represented with N, small letter N. Right? Something like that. So it's going to be N1, N2, N3, N4. And these are all levels or energy levels or principal quantum number. Okay, for example, in the science examination, we say, what do you call a principal quantum number? A, sub-level. B, ganun siya, electronic configuration. C, energy level. D, Lewis dot structure. E, none of the above. Your answer will be energy level or principal quantum number. Okay? Like that. Okay. Now we go to the secondary. If we have the principal, we have also the secondary quantum number. So we go first to the leveling. So we need to say energy sub-level. Okay, energy sub-level meaning under the level. Because of the word sub, S-U-B, English. So sub-level. Okay, now secondary quantum number. Okay, secondary quantum number. Okay, like that. Or another term, I will give you the maximization of terminology so that we can have an idea during examinations in the future. It can be used interchangeably, but it has the same meaning so that you will not be confused. Oh, I will encounter a new term for this, and then nah. Actually, it has the same meaning only. Okay, subshell. Okay, subshell. Okay, subshell, sub-level, energy sub-level, and secondary quantum number are all the same meaning. It depends on the utilization of the particular topics in the reference textbooks that you are dealing with or in the future examinations, particularly science examinations, specifically chemistry, of course, right? Okay, now this is referring to S, P, D, and F. So I will say S sub-level, P sub-level, D sub-level, F sub-level, S sub-shell, P sub-shell, D sub-shell, F sub-shell, and these are all secondary quantum numbers. Oh, like that. Okay. Now we have the magnetic quantum number. What is magnetic quantum number all about? Kaloka. Diba? Magnetic quantum number. Okay, guys. Magnetic quantum number is ML. M stands for magnetic quantum number, and L stands for, later I'll be talking Azimuth quantum number, later na lang siya. Okay, so this is dependent with the orbital. Okay, for example guys, I will take note here, the beryllium. Okay, beryllium has an atomic number of 4 and a mass number of 9.01. Okay, when we deal with electronic configuration, always focus on the atomic number. Okay? Because the atomic number will represent the behavior, characteristic, property of an element, of an atom. You get a point? So something like that. So based always in the atomic number. Not the atomic weight, not the ANU or the atomic mass unit. Okay, and not the mass number, not also the charge, not also the valence electrons in the outermost shell. Okay? Always base that to the atomic number. Okay? Very clear. Okay. Now, if I have the beryllium, okay, this one is the beryllium, ganon. Okay, beryllium. Okay. So the beryllium, for example, have 4, gonna chuba chuchu. Okay. Assuming, because I don't have the configuration yet, assuming that this 4 is the orbital, okay, you have to put 4 orbital. 1, 2, 3, 4. Ganon. Okay. And then, since each orbital will only occupy a maximum of 2 electrons, remember this is theory. Each orbital will be composed of 2 electrons only to occupy. This is now the Pauli Exclusion principles. Okay? Okay, again, each orbital in the sub-level SPDF will only occupy maximum of 2 electrons with opposite spin, something like that. But you have to feel first the level before going to another level, before changing the spin. What does it mean? Now I will draw now. Okay, if I have the 4 electrons here, so first consider in going up and later in going down. Since we have 4 orbitals, complete first the orbital. Okay, the 4 orbitals before going back. Okay, now like this. Arrow up, second orbital, and then in the second round, all will be going down. Okay, okay, the going up and the going down is our magnetic spin. Okay, the magnetic spin, which we are not yet discussing it. Okay, like that. But our ML, guys, the magnetic quantum number, it is the last counting in which the arrow will stop. Okay, for example, if it's 4 electrons, 1, 2, 3, 4, it will stop here. And this is your ML here. Okay, now you count that 1, 2, 3, 4, and your ML will be 4. Okay, basing on the SDPF orbital it contains in each subshell. Okay, nag-unar ako, pero wala siya ang mono kadiri. The last arrow will be your magnetic spin if it goes up and down. Now, if it goes up, it will become the positive 1/2, and if it goes down, it will be the negative 1/2. There's no other magnetic spin of the electrons in an orbital, only 2, positive 1/2 and negative 1/2. Okay, and that's very clear. Because will come out also in the choices like this. What are the 2 magnetic spin of an electrons that it occupy in each orbital? Mag-ibog din ka. So your answer will be positive 1/2 and negative 1/2 only. Okay, ganon. So I will erase this. So this is the ML. ML gani, kung asa siya ni stop ang last arrow, then that would be your counting. Nasa siya sa 0, nasa siya sa 2. So your ML will be 2. Kung nasa siya sa 1, your ML will be 1. Something like that. Later I will give you an example also to understand further. Okay? Like that. And now we go to the azimuthal quantum number. Okay, azimuthal. Azimuthal, guys. Charot. Azimuthal quantum number. I hate this. Okay? Azimuthal quantum number. When I was in my first year college 20 years ago, I didn't understand very well about azimuthal. Okay? It is the time when I go abroad, places to places. For example, I go to Taiwan, I go to Qatar, I go to Abu Dhabi, United Arab Emirates, in the Philippines, of course, it's my country of origin, and I go to Saudi Arabia during day offs. Going to vacation, I always scan my books because I love really to read. Okay, read, even though I'm already a licensed chemical engineer, I still have to read books, something like that, and try also to manage solving problems. Really, even though I'm already graduate, something like that. I really love to read like this, explore more. So meaning to say, my learning will never stop. Okay, related to science only because I love science, particularly chemistry and physics, something like that. Okay, now I really discovered, guys, this azimuthal quantum number in which I confused before, and now I really understand. And this is the L. Okay, and this L will be dependent on the subshell. The S, the P, the E, and the F. Like that. Okay. So the formula of L is, okay, 2L plus 2. What you kabaw ano sa unang guys? Oy, if I know pa lang, charot. Okay, 2L plus 2. Okay. Diba? I was aiming to become a top-notcher before, right? And I'm very, very ambitious. Very high aim. Something like that. And then, if I know this stuff a while ago, like that, I know the techniques also how to calculate in a straightforward manner, then maybe, I don't know, okay? Something like that. Okay, because I already memorized a lot of operations and processes, theories, concepts, and principles talaga ako eh. Okay, so 2L plus 2, right? And then if you multiply this L here will be the azimuthal. Okay, if you know the azimuthal number, then you know the number of orbitals in which this sub-energy level subshell can occupy. In which I don't know this before in my chemistry. Maybe I was sleeping or I don't pay attention too much with the instructors or the mentors, probably, right? Okay, something like that. Okay, this is azimuthal quantum number L. Basing so that we can compute the number of orbitals in each subshell. Ganon. And the last will be the magnetic spin. Ito kung hingon ninyo na, okay, positive 1 half and negative 1 half. Magnetic spin. So magnetic spin, okay, this is positive and negative 1 half, so MS. The magnetic spin is responsible for the, microchips components in your mobile phone. How they behave to highly sensitive chemicals that will try to contaminate in your mobile phone, because it made up of a lot of electronic chips, electrons. Okay, the spin is very important. How they cope up or to respond to situation, or in biology we call that as a stimuli. How they reply to certain stimuli. Stimuli meaning a lot. We have substances, chemicals, fluids, like that, outside factors, the sunlight. So that's stimuli in your environment. So for example, if your mobile phone is reacted to a flammable something like that, it will explode, right? So the magnetic spin is very sensitive. The electronic magnetic spin of that electron is very sensitive in your electronic microchips. So that is the concept of this electronic configuration, and this all are found in our electronic gadgets. Okay, laptop, mobile phones, okay, appliances, okay, name it. All about electronics devices. Okay, so like that. So we have overview of our learning outcomes: energy level, energy sublevel subshell, magnetic quantum number ML, azimuthal quantum number, okay, like that L, magnetic spin NS, like that. 6 siya, 5 siya. Okay, ganon. Okay. Thank you so much for watching. I already done with us, overview. Later I will be able to show you examples also how to compute. Okay, thank you so much for watching. If you like and share and comment this video, you can. It will be much appreciated by me, of course. And then you can subscribe my channel if you like also, and I will be very happy to that. And you can click the notification bell for some US updates of the Singer Journal Voice. Bye-bye! God bless everybody! See you later, mga palangga, for my next session on segment. Hello ka.